Right, now here I've got an SPSS file which is called chest pain. I happened to open earlier just because I wanted to check out its format. So if you look at this particular file, what can you see about this data? What kind of data is it? I've got something that says here pain, and I've got something that says here gender. So is this quantitative or qualitative data? It's 100% qualitative. It's not quantitative at all. There's no continuous numerical scale. If you look here at the top, you can see pain is nominal. Gender is nominal. They're represented by 1 and 0s and 2s and things because they've been coded. If I go to view and value labels, it goes yes and male or no and male and female. So this is to do just to show you the file, but there's just gender and there's yes and no. Now I want to analyze this. So if I've got data like that, what can I do to analyze it? I need to count up how much there is in each group. So what I've got is as a hypothesis is, are you likely to have chest pain if you're male? Is the probability that you have chest pain as a male equal to the probability of you having chest pain as a female? That is my hypothesis. It's exactly to do with probability. My null hypothesis is to assume that the probability of having chest pain doesn't depend on gender. Alternative hypothesis is it does depend on gender. So we test that using the chi-squared test. That is the standard test for association between a variable and changing the probability. So you need to do what's called a cross tabulation. You go to descriptive statistics, cross tabulations. Now, you think that gender is the influencing factor that might cause chest pain or not. So gender is the cause and must go into the rows. Chest pain is the effect, the thing that happened, and goes into the column. So gender is the independent variable, pain is the dependent variable. You can do something called an exact test, which would work in this particular case. You can do the next thing below it is called statistics. So if you click on that button statistics, it asks you what kind of statistics you want to do. And I said this is the chi-squared test. So you need to click on the chi-squared test button. If you've got a table which has 2 rows and 2 columns, which I think this one does, and you can also click on this button, which is called the risk. That will calculate the odds ratio. It's called risk, which is a bit annoying because it isn't. It's going to calculate odds ratios, not relative risks. If your 2 things are not independent of each other, so if you're doing a diagnostic test and you've got method 1 compared to method 2, and you've got yes, you diagnose or no, you don't, then because that data is paired, they're not independent of each other, then you would click on McNamara instead of clicking on chi-squared. I'm not going to be that devious, but you might have it in one of your projects. Another thing you can do is Cochrane's Mantel-Hinsel statistics, which have a very specific use. So if you know you need to do that test, this is where to find it. Otherwise, just ignore it. Press continue. And then I just go OK. And I've finished. I've done everything I need to do for a chi-squared test within SPSS. So the first thing it's done is calculated that there are 474 men that have no pain, 46 men have yes to chest pain, 516 women have no chest pain, 37 women have yes to chest pain. The total number of people who don't have pain is 990, the total number who do is 83, Total number of men is 520, total number of women is 553. The total number in the task study is 1,073. The chi-squared test is this row of the table that says Pearson's chi-squared. This number here, 1.744, that is the chi-squared statistic. Degrees of freedom is the number of rows minus 1 multiplied by the number of columns minus 1. And this is the p-value. So in this case, it's 0.187. If that value is not less than 0.05, then there is not a significant difference. So that means the probability of having chest pain is the same in men and women. There's no difference between the two groups. Because this is a table which is 2 by 2, you can or you should apply something called Yates continuity correction. So that changes the value of the test statistic to be 1.456, 1 degree of freedom, and your p-value is 0.228, so even less below 0.05. Sometimes you might find that your particular field or area prefers to use likelihood rather than chi-squared, because likelihood is a more modern method. In this case, the test statistic is 1.745 and the p-value is 0.186, so they're exactly the same. The answer would be 1.456 if I asked for the test statistic, or it would be 0.228 if I asked for the p-value. Then you've got the odds ratio and the confidence interval. So on average, the odds ratio is 0.739, but the confidence interval goes from 0.471 to 1.159. So that includes a value for the odds ratio of 1, meaning the two are exactly the same. So this is telling you there's no significant difference in chest pain between men and women. And that's absolutely all the analysis you could possibly want to do with that particular set of data. I've got another set of data which is vaguely more interesting because it actually does contain a significant difference. Right. So when you get an SPSS file, I want to do the lung cancer one. You just double click on it. That is as hard as it gets to opening SPSS. Right, so this set of data has smoker and cancer. There's a lot of smokers. Looks like it's quite a long file. Yeah, there's lots of smokers with yes. There's some smokers with no. It's a very long file. We still haven't got to the non-smokers yet. Okay, there's some non-smokers and they've got no cancer. So in total there are 2,714 people. That's a little bit of an inconvenient thing. I think that this is actually the data from Richard Dole's original study. I can't absolutely be sure of that. I do have his data around, and I might have used it to make this, or I might not. So you do exactly the same process. Let's explore. Sorry, not to explore. Let's analyze descriptive statistics crosstabs. Smoking is the thing that I think causes cancer. Cancer is the dependent variable outcome. I want to put on my statistics again. I want to put on chi-squared. I can put on the risk ratio because again this is the 2 by 2 table because I've got smoking, non-smoking, yes cancer, no cancer. Press continue and press OK. In this case it tells me that of the non-smoker 152 don't have cancer, 56 have cancer. Of the smokers 1,205 don't have cancer, but 1,301 do have cancer. In total there are 208 non-smokers, 2,506 smokers. Do you think that that is a correct proportion of the population? So if I went out and got 2,714 people, would I end up with 2,508 smokers? So this is an example of what you call a case control study. So what this tells you what the probability of getting of the relationship between smoking and cancer is, because I go and find people who've got cancer. But it doesn't tell you the incidence rate of cancer in the population. It just tells you the increased risk for this specific for cases against controls. So it doesn't give you an absolute risk, it gives you a relative risk. That's important to understand. Right, now in this case, the chi-squared statistic is 47.985. That's big, like massive. 1 degree of freedom. The p-value is so small that it's being recorded as a 0. So it's not less than 0.00005. If it was bigger than that, it would be, you'd have 1 digit here. The continuity corrected version, the Yates one, is practically the same. So 46.991, 1 degree of freedom, still naught. Likelihood ratio 49.971, and still naught. There's absolutely no chance that smoking is not related to cancer. And then you can look at the risk ratio. So it's telling you that the smokers are 2.931 times as likely to have cancer than the non-smokers. The p-value is significant whenever it's less than 0.05. Right, so that's done that way. Oh, and the confidence interval for the odds ratio is from 2.1 to 4.0. So that means the amount that smoking increases your chances of getting cancer is between 2-fold increase or 4-fold increase, between 2 and 4 times as likely to get cancer as a smoker.